Qualitative graphs. Vocabulary. Qualitative graphs are used to represent situations that may not have numerical values, or numerical values may not be given to us. Example 1, describe the temperature throughout the day. So here we have time of day and temperature. And as you all know, that as the day goes on, it warms up. And then around noon, here's about halfway through the day, it starts to get cooler again. So usually it's cool in the morning and cool at night. And we could even go so far as to say that this would probably be 0 degrees. It goes up to some number, we don't know, and then it goes back down to the same temperature it started at. Example 2, a tennis ball is dropped on the floor. It bounces several times before it stops. Draw the graph. So, think about dropping a tennis ball on the floor. It's some height to begin with, and it drops, it hits the floor. And then what happens? The ball bounces back up, but it doesn't bounce up quite as high as it started with before. And each successive bounce, it hits the floor and bounces up to a height not quite as high as it was before. And this continues on until the ball stops. Example 3, a child swings at the playground. Draw the graph. So most of you, probably all of you, have been on a swing set before. And you know that the swing is not sitting on the ground. So the swing is at some resting height. And you swing backwards, and you go up, and then you go down, and you go up, and you go down, and you go up, and you go down. And this continues until you get off the swing. Interpreting graphs. A student walks and takes the bus to get home from school. So we're going to look at this graph. It's talking about time it takes to get to school and the total distance that a student walks. Now, we need to talk about which pieces of this function or of this graph are showing us where the student is walking and where the student is taking the bus. And since we've been talking about rate of change, you should be able to see that this rate of change and this rate of change are exactly the same. The slope of these two lines are exactly the same. So, these are the same, and they are not as steep as this piece. So, these mean something slow is happening. He is walking in these two places. And since the slope is steepest right here, we can assume that at this part, the student is on the bus. Now, what would cause the graph to be flat? Well, the bus isn't always there when you get to the stop. So here, he is waiting on the bus. He's not moving. He's sitting there at the bus stop, burning some time. So, a steeper slope means something faster is happening, and a less steep slope means something slower is happening. Increasing, decreasing, and constant. So the scenario is you fill up your bathtub, but you do not get in. You wait a few minutes, then you let the water drain out. So here is time and the amount of water in the bathtub. Now we just talked about in the previous slide that if the line is steep versus less steep, that something's happening faster and something else is happening slower. So this line is really steep compared to this part of the line. When you put water in your bathtub, it happens faster. And as water drains out, that happens slower. This is a constant rate of change. Nothing is happening. The water's not going in, the water's not going out. The water in the bathtub is staying the same. This happens during the wait a few minutes part. All right, so fill-up is steeper than draining out. What does this mean? It means that the water goes into the tub faster than the water drains out. This line is increasing. It has a positive slope. This line is decreasing. It has a negative slope. And this line is constant. The slope is 0. And I'm sure that you are familiar with slope dude. And this is the slope face, a positive slope, a negative slope. A vertical line has an undefined slope, that's what the U stands for, and a horizontal line has a 0 slope.